दिस इज Omprakash Yadav. तो एक नया न्यूमेरिकल आया हुआ था वेल्डिंग प्रोडक्शन में, सोचा सॉल्व कर देता हूँ आपके लिए। देखते हैं क्या है। मॉर्निंग सेशन में था सेट 1 में, बिल्कुल एकदम नया प्रॉब्लम आया हुआ है वेल्डिंग न्यूमेरिकल। देखते हैं इसको थोड़ा क्या दिया हुआ है। 2 mild steel plates of similar thickness in butt joint configuration are welded. So there are 2 mild steel plate and this both the plate are similar and they are put end to end. Okay, so in butt joint configuration they are joined. One plate is this and another is this. In butt joint configuration they are jointed. Okay, so let us see. By the gas tungsten arc welding process using the following welding parameter. So what is the welding parameter that is given? क्या दिया हुआ है? Welding voltage. This V is equal to 20 volt. Welding current I is equal to this 150 ampere. And welding speed. Let us denote welding speed by Vs. So it is given as 5 mm per second. So welding speed is 5 mm per second. 5 mm per second. Then let us see a filler wire of same mild steel material. So whatever is the material of this 2 sheet, that is mild steel, and the same material is the filler metal. This is the filler metal. Okay, of 3 mm diameter. Diameter of this filler metal wire is 3 mm, so D is equal to 3 mm. D is equal to 3 mm is used in this welding process. The filler wire feed rate is selected such that the final weld bead is composed of 60% volume of the filler and 40% volume of the plate material. Okay, so out of this 20, if you see from this side, you can see what is the bead geometry. So this is the bead geometry. So what they are telling, out of this total 60% is compensated, is given by this filler material. 60% is filled by the filler material and 40% itself is melted by the workpiece. 40% is melted from the workpiece and 60% is melted from the filler metal. Okay, so out of this total area, total volume, total material in the bead geometry, 60% is filled by the filler material. So let us say this one is 60%, this one is 60%, and this 60% is filled by filler metal. Remaining this 40% is filled from itself melting the workpiece material. So only 60% is filled by this filler metal. Okay, let us see. The heat required to melt the mild steel material is 10 joule per mm cube. Actually, you can say the specific energy of melting also to this term. In metal cutting, you are saying the specific cutting energy. In welding, you are saying the specific melting energy. So that is 10. I am denoting this by the HV, heat needed to melt per unit volume of the material. So HV is equal to 10 joule per mm cube. 10 joule per mm cube. The heat transfer factor is 0.7. So you can say the heat transfer efficiency that is 0.7. So heat transfer efficiency neta T is equal to 0.7. And the welding factor means you can tell the welding efficiency, melting efficiency. Melting, let us say this is neta m, so melting efficiency or factor neta m is equal to 0.6. This is given. Now let us see that what they are asking. The feed rate of the filler wire in mm per second. mm per second means speed. ठीक है. So look at here what they are asking. So welding speed is given. So this is melted, deposited. Some of the material is melted from the workpiece, and they are moving. The speed at which you are moving forward, that is the welding speed. Let us say this is Vs, and this welding speed Vs is given as 5 mm per second. 5 mm per second, and out of total 40% is filled by the filler metal, and the remaining 40% itself from the workpiece material is getting melted. So only 60% is compensated, is filled by this filler metal, and the diameter of the filler metal is given. Okay, very good. So what they are asking, at what speed this material is fed? At what speed this material is fed? Let us say this is Vf. Vf is the feed rate. Yeah, velocity at which actually what is happening, this wire is getting consumed. So this will come down, this will come. As you are moving, this will come down. So at what speed they are coming down? That is the feed rate, yeah, speed of the filler metal towards the workpiece. Let us say it is Vf. So your objective is to find out what is this Vf. Okay, feed rate of the filler material. So before finding this, first of all, you have to find out what is the total cross-sectional area of the bead geometry. What is the total cross-sectional area of the bead geometry? So up to that, it is old one. So new is when you are going to find out the feed rate. Okay. So what is the new? I will see later. First, find out the cross-sectional area of this bead geometry. So for this, first of all, you calculate what is the heat input, what is the heat required, needed. So first of all, heat input to material. Heat input to material, let us say this is HI. So this V into I, because this voltage and the current is given. So this VI into also this heat transfer efficiency is given. Total VI is not going, is not entering into the material. Out of some is getting lost. So only NT is equal to 0.70, only 70% is going into the material. So neta is the heat transfer efficiency, so multiply by neta, heat transfer efficiency, then you will get actually how much energy is entering into the material. So let us put all the value. So this V is 20, I is 150 ampere, and the heat transfer efficiency neta of T is 0.7. When you multiply, you will get this as a 20. 100. What will be the unit? Let us see. This is VI. So watt. So in watt per second, 2100 joule per second energy is entering into the material. Similarly, you find out how much is needed. Number 2, heat needed for melting the material. Heat needed for melting the material. Heat needed for melting the material. Let us say this is HV. This is HM. This is HM. So HM. For the welding, I have developed the formula, and they are applicable. Okay, so I am applying my formula, what I have developed, what I have. So HM is equal to this HV. So what is this HV? This one, 10 joule per mm cube. Means energy needed to melt the per unit volume of the material. Per unit, this V for per unit volume. So heat needed per unit volume of the material into what I am writing, the welding speed. So welding speed, let us say this is a Vs into cross-sectional area of this bead geometry. Cross-sectional area of bead. Let us say this is a AC. This is AC. So let us put all the value what you have. So HM is equal to HV. HV is 10. Also you write the unit joule per mm cube. Also you have to check and balance the unit. In production, you have to take very critical care of your. Okay. So welding speed, it is a 5 mm. It is 5 mm per second. 5 mm per second. into cross sectional area of the bead geometry, which first of all you have to find out. Let us say it is AC, and you will get this in mm square. I want to find in mm square. Acha, first of all let us take the unit. So this is mm cube, mm square. So mm square mm, this mm cube. This becomes mm cube, and mm cube is getting cancelled out. So joule upon second. So this becomes joule per second, that is watt. So how much you are getting this HM? So HM is equal to this 50 into AC, cross sectional area of the bed, this much watt. Look at here, this heat input is in watt, and the heat needed for melting the material also is in watt. Both should be in the same unit. Both should be in the same unit. Now the melting efficiency or factor neta m is given. So melting efficiency neta m is equal to this HM divided by HI. So this is in fraction, so there is no need to multiply by 100. Clear है? तो 100 से गुणा यहाँ पे नहीं करेंगे क्योंकि ये ऑलरेडी आपको फ्रैक्शन में दिया है. So neta m is 0.6. That is given. Melting efficiency or factor neta m is 0.6. HM is this 50 into AC divided by heat input. This is 2100. This is 2100. So from here we are getting cross sectional area of the belt. How much we are getting? Oh, this is 25.2. I have calculated 25.2 mm square. So cross sectional area of the belt is 25.2 mm square. Okay. So this is the total area. This is the total area which is not filled by this filler material. Only 60% of this total area is filled by this filler material. Remaining 40% itself from the melting of the workpiece material. So you don't take this area for further calculation. Okay. Now let us see. So out of this total 60% is filled by the filler metal, and 40% itself melted from the workpiece material. So only 60% out of this total volume 60% या डेंसिटी सेम है तो आउट ऑफ टोटल सरफेस एरिया भी आप बोल सकते हो क्योंकि लेंथ तो सेम ही होगा, और फिलर मेटल का और वर्कपीस मटेरियल का दोनों का ही मटेरियल सेम है, डेंसिटी सेम है, तो आप वॉल्यूम सेम की भी बात कर सकते हो. सो यहां से ओनली 60% ही फील होगा, 40% आपका वर्कपीस से ही मेल्ट होगा, तो आप केवल 60% लेके चलेंगे. तो आप ये देखो कि आपका टोटल का कितना फिलर मटेरियल ने फील किया. ओके, उसको पहले हम लोग निकालते हैं. सो एरिया filled by the filler metal. Let us say this is A2. ये क्या हो जाएगा? Only 60% of total. So 0.6 of total, and this is what? 25.2. So how much you are getting? It is a 15.12. 15.12 mm. So out of total area, this 15.12 mm square is filled by the filler metal, and the remaining from itself melting the workpiece material. Okay. This is A2, this is A2, and this will be V2. This will be V2. Now the beauty has started. What is the problem in this problem? What is the problem in this problem? So what is new? What is new? Up to this, finding the efficiency and a cross-sectional area of welding speed, these are as usual. So always they are asking this kind of question. So what is the new? Let us see. New is that this time they have asked what is the filler material speed, yeah, feed rate. Okay, so this is totally new, but just by applying a very simple fundamental of mass conservation, that is continuity, this problem can be solved. Let us see that how I am going to apply the continuity question. Look at here. So mass flow rate of this as they are melted, mass flow rate of melting of this material जैसे जैसे मेल्ट करेगा उसी रेट से तो आगे बढ़ेगा. तो जिस रेट से यहां से मेल्ट करेगा उसी से अगर आप कंटिन्यूटी लगाओगे तो क्या आप कैसे अप्लाई करोगे? A1 V1, इसका क्रॉस सेक्शनल एरिया A1 इंटू इसका स्पीड V1 इज इक्वल टू A2 V2. उतनी स्पीड से तो आगे जाएगा, कंटिन्यूटी इधर अप्लाई करेंगे. A2 V2 तो किस स्पीड से आगे जा रहा? वेल्डिंग स्पीड BS से आगे जा रहा, लेकिन जो टोटल एरिया उतना तो ये फिल कर नहीं रहा. कितना एरिया फिल कर रहा? ओनली 60%, इसलिए हमने A2 क्या ले लिया? 60%. तो यहाँ पे A2 क्या हो जाएगा? केवल टोटल का 60%, लेकिन स्पीड तो वही होगी जो वेल्डिंग स्पीड होगी, तो V2 क्या हो जाएगा? Vx. तो A2 तो ये हो गया, और V2 क्या हो जाएगा, V2 इज इक्वल टू V ऑफ फीड रेट, स्पीड ऑफ दिस फीड रॉड, filler rod, speed of the filler rod. So V2 is equal to V of. Now let us find out. Oh, sorry. This V2 will not be the V of. V2 will be the welding speed. One I am taking at here. At what speed and the cross sectional area this is coming, and at what cross sectional area and the speed this is moving. So A2 is here. कितना इसका क्रॉस सेक्शनल एरिया जो ये कंपनसेट कर रहा, ओनली वो जो कंपनसेट कर रहा फिलर मेटल वही लेंगे, वर्क पीस का नहीं लेंगे A2, और कितना स्पीड से जाएगा वो V2 हो जाएगा। तो V2 इज इक्वल टू वेल्डिंग स्पीड विच इज गिवन 5 mm per second, which is given 5 mm per second. Now let us see what is the cross sectional area of this filler material. Cross sectional area of the filler material, so its diameter is given. So cross sectional area of filler material, that is A1 is equal to pi by 4 d square. So this pi divided by 4, d diameter is 3 ka square. So I am getting a 7 point, how much I am getting, 7.0685 mm square. So cross sectional area of this filler material is A1. Let us say this is A1, 7.06858 mm square. And what will be V1? V1 will be the speed of this feed rod. So V1 is equal to what? V1 is equal to V. Speed of क्या feed rod? Speed of the feed rod, या feed rate भी आप बोल सकते हो उसको, feed rate भी बोल सकते हो। अब हमें A1 A2 पता है, A2 V2 पता है, A1 V1 पता है। अब कंटिन्यूटी अप्लाई हम करने जा रहे हैं। फिर से थोड़ा सा ध्यान दो आप, मैं पूरे पे कंटिन्यूटी नहीं लगा रहा, क्योंकि ये जो पूरा यहाँ पे मटेरियल फील्ड हो रहा है, टोटल का टोटल यहाँ से नहीं आ रहा, कुछ वर्क पीस से मेल्ट होके आ रहा है, कुछ फीलर मटेरियल से आ रहा है। तो जो फीलर मटेरियल से आ रहा हम उसी को आगे अप्लाई कर रहे हैं कि जो वर्क पीस से मेल्ट होके आ रहा, तो टोटल का यहां से जो आ रहा उसमें से टोटल का केवल 60% फील्ड हो रहा, 60%। इसलिए इस बीट ज्योमेट्री का हमने क्रॉस सेक्शनल एरिया कितना ले लिया, केवल 60%। ओके, अच्छा अब आ जाओ 60% क्रॉस सेक्शनल। एक्चुअली अंदर में जो लेंथ होगा वो तो सेम होगा दोनों ही केस में, इसलिए लेंथ वॉल्यूम लेने की जरूरत नहीं, क्योंकि लेंथ आपका कैंसिल आउट हो जाएगा। अच्छा, डेंसिटी भी सेम है, तो फिर आपका कंटिन्यूटी में रो और रो टू कैंसिल हो जाएगा। डेंसिटी सेम है तो आप सीधे A into V is equal to कांस्टेंट अप्लाई कर सकते हैं। आइए अप्लाई करते हैं हम लोग। Let us apply the continuity equation and find out the final answer. So from the continuity A1, V1 is equal to this A2 V2. Let us put all the value. So A1 is 7.0685 into V1. So V1 is V of feed rate. A2 कितना आया आपका? This is 15.12 into V2. So V2 is equal to welding speed. It is 5 mm per second. This is in mm per second. So also this will be in mm per second, because this area will consider out. Okay. So how much we are getting the feed rate? V of is equal to, so it is coming out to be 10.6952 mm per second. So ये एरिया का डायमेंशन कैंसिल आउट हो जाएगा, तो जो इसका डायमेंशन होगा वही VF का डायमेंशन होगा। mm पर सेकंड है तो VF भी आपका mm पर सेकंड में आएगा, और mm पर सेकंड में ही आपसे पूछा गया है। तो फाइनल आंसर आपका ये है। क्या पूछा था आपसे, डायमेंशन भी चेक करेंगे। द फीड रेट ऑफ द फीडर वायर इन mm पर सेकेंड, इन mm पर सेकेंड, तो mm पर सेकेंड में ये आपका आया हुआ है। तो जिस स्पीड से आपका आगे बढ़ेगा फीड होगा वो निकल के आपका आगे। अच्छा, एक चीज और, ये तो हो गया अभी के लिए। अब आगे न्यूमेरिकल आएगा, ये पहली बार इस पे आ गया, बिल्कुल नया वैरायटी है, नया कॉन्सेप्ट है। अब इसमें आगे फिर से सवाल पूछेंगे साल 2 साल में, तो फिर थोड़ा सा मॉडिफाई करेंगे। क्या मॉडिफाई करेंगे, यहाँ पे फिलर मटेरियल और आपका वर्कपीस मटेरियल का सेम मटेरियल दिया हुआ है, सेम डेंसिटी भी सेम हो जाएगा, डेंसिटी सेम हो जाएगा। तो फिर आपका यहाँ पे ये रो 1 और यहाँ पे रो 2 लगाने की मुझे जरूरत नहीं थी। सेम मटेरियल था फिलर का और इसका, ये आपका रो 1 रो 2 कैंसिल हो जाएगा, सेम डेंसिटी हो जाएगा। ठीक है, अब आगे क्या करेंगे, आगे आपको दोनों का अलग अलग मटेरियल कर देंगे, तो दोनों की आपको डेंसिटी भी दे देंगे। फिलर का, वर्कपीस का, बोलेंगे अलग अलग मटेरियल का है, इनका डेंसिटी क्या है, अलग अलग है, डेंसिटी अलग अलग है। तो जब ऐसा होगा तो आप यहाँ पे रो 1 और यहाँ पे रो 2 ले लेंगे, क्योंकि मास कंजर्व होता है। ठीक है, तो फिर रो 1 इधर और इधर रो 2 कर देंगे, तो रो भी मास फ्लो रेट इधर और आगे का मास फ्लो रेट रो 2 इनटू V2, इसको लेके चलेंगे। मटेरियल सेम है इसलिए हमने यहाँ पे डेंसिटी नहीं लिया है, डेंसिटी कैंसिल आउट हो जाएगा। क्लियर है? सो आगे का जो सवाल पूछेंगे तो मटेरियल डिफरेंट करके पूछेंगे, सिमिलर प्रॉब्लम नहीं पूछेंगे। ओके, थैंक यू वेरी मच।